All right, let's go over the answers to that practice test. So first question, we had to simplify 8 to the 4/3 power. So the way I would do this is first rewrite it as a radical. So since it's 8 to the 4/3, the 3 is in the bottom. So that means it's the root. So cubed root of 8 raised to the 4th power. Now the reason it's easier to write it like this is because the cube root of 8 is just 2. And if you don't know that, you can always go to your calculator here and find the cube root of 8, and that is 2. So cube root of 8 is 2, 2 to the 4th, which is 2 times 2 times 2 times 2, which is the same thing as 4 times 4, which is 64. That is not true. I don't know why I just said that. It is 16. Sorry. So 16, which was letter D. All right. Second one, we had to rewrite 8 to the 1/6 power using radical notation. So this one is pretty straightforward. It's just 18 under the 6th root. Oops. Next one, number 3, we had to evaluate using a calculator. So 7th root of 4,983. So here we go. Let's clear that. So we've got the 7th root of 4, underneath 4,983, and that is 3.375. Now, if you're using your TI-84, here are the steps you want to take. So you turn it on, you just hit the number 7 first, so hit 7, and then the math button, and then you go down to number 5, so number 5 on the list, and then you type in 4,983, and what you should see at that point is 7,4,983, and then you hit enter, and that should give you your answer. So number 4, we want to evaluate this using a calculator as well. So this is 256 to the 3/4 power. So on your calculator, you just do exactly what it says. So 256 raised to the 3 divided by 4 power, and that is 64. So if you're using a TI-84 or something similar to that, you type 256. So 256, and then the caret button, which is underneath the clear button. It's above the division on the TI-84. And then do parentheses, 3 divided by 4, close parentheses, then hit enter. All right, number 5, we need to simplify using properties of radicals. So some of you on the quiz, you made this a little harder than it had to be. So all I'm asking you to do here is use the property that says that you can combine them like this. That's all you need to do. And since this is a 2 and a y, you can't simplify that any further. And you can leave it just like that. That's fine. That's all I'm asking. So this was number 5. All right, number 6, similar idea. So cube root of 40 times 4 times the cube root of 5. So this 4, I'm just going to bring that out in front. So we have 4 times the cube root of 40 times the cube root of 5. Again, all I'm asking you to do is combine. We don't need to get too crazy here. If you leave it like this, I am satisfied. All I want to know is that you know how to use the rule, that you're allowed to combine what's underneath the radical, underneath one radical, like that. All right, so 7, simplify using properties of exponents. So we've got x to the 1/2 times x to the 1/4. So since it's multiplication and we've got the same base, we can add them. So 1/2 plus 1/4. We need a common denominator, so I am going to take this 1/2. Let's make it have a denominator of 4, so multiply this by 2/2. And then we've got x to the 2/4 plus 1/4, which equals x to the 3/4 power. Okay, number 8, similar idea. So we've got x to the 4/3 over x to the 2/3. Since it's division, that means we can subtract. And conveniently, we already have a common denominator here. So this is going to be x to the 4/3 minus 2/3 power, which is just 2/3. 4 minus 2 is 2. Nine is pretty much the same thing, actually. The only difference is this time we have a number in the base. So we have 49 to the 5/6 power over 49 to the 1/3. So since we have the same base, that means we can subtract the exponents. Since we have two different denominators, we need them to be the same. So we've got a 6 here and a 3 here. So let's take the second fraction, multiply by 2/2. And then we have 49 to the 5/6 power minus 2/6, which is 49 to the 3/6 power. Now 3/6, we can reduce that to 1/2. And I noticed something interesting here. So 49 to the 1/2 is the same thing as the square root of 49, which is just 7. So I will say if you left it like that, it would be correct. But if you take it a step further and write 7, I would also mark that correct. All right, next page, number 10. So this is dealing with our functions, our power functions. So for number 10, we have f of x equals x squared minus 5, and g of x equals 3x squared. We need to find g of f of x. So for this, g of f of x, so we're going to plug in f of x into g. So what we're looking for is g of x squared minus 5, which means we plug in that x squared minus 5 for x into g. So that's going to be equal to, since g of x is 3x squared, it's going to be 3 plug in x squared minus 5 squared. You can just leave it like that. All right, number 11. So we have f of x is 25 plus x. G of x is 5 minus x. First, we need to find f of x plus g of x. So we just need to add these two functions together. So it's going to be 25 plus x plus 5 minus x. I'm going to combine like terms. So let's do the x's first. So x minus x plus 25 plus 5 equals x minus x is 0 plus 30. So our answer is just 30. B, we need to find f of x minus g of x. So that's going to be 25 plus x minus 5 minus x. Now, since this is subtraction, it's really important that you keep these in parentheses, because if you don't, then you will most likely forget to distribute this negative to both the 5 and the negative x. So that's going to be equal to 25 plus x. I don't really need that parentheses anymore. So 25 plus x minus 5 plus x. So I'm distributing this negative. Now we combine like terms. So we've got x plus x, and we've got 25 minus 5. So this is going to be 2x plus 20. All right. Now we're on to number 12. All right, so for number 12, we have f of x equals 16x to the 1/3, and g of x equals 2x to the 2/5. For part A, we need to find f of x times g of x. So we just multiply these two things together. So that's going to be 16x to the 1/3 times 2x to the 2/5. So first of all, let's multiply the coefficients. So 16 times 2 is 32. Then we have x to the 1/3 times x to the 2/5. So let's deal with that now. So since this is multiplication, we can add the exponents. So this is 32 times x, the 1/3 plus 2 over 5. Now we need a common denominator. So we've got a 3 and a 5. So let's turn those into 15. So this first fraction, we're going to multiply by 5 over 5. This second fraction, we're going to multiply by 3 over 3. So then we have 32x to the 5 over 15 plus 6 over 15. So again, let's put these in parentheses just to make it really clear that that's our exponent. So then we have 32x to the 11 over 15. And that's it. You can't simplify that any further. So for part B here, we are looking for f of x over g of x. So that's going to be 16x to the 1/3 over 2x to the 2/5. So again, we can first deal with the coefficients. So we have 16 divided by 2. So 16 over 2 here is just 8. And then since these have the same base and it's division, we can subtract the exponents. So then we have x to the 1/3 minus 2 over 5. And we're going to do common denominators again, and they're going to be exactly the same as the last one. So it's going to be these same exponents here. So now we have 8x to the 5 over 15 minus 6 over 15, which equals 8x to the negative 1 over 15. Now, I don't like negative exponents in my final answer, so I'm going to move this x down to the bottom into the denominator. Now, we don't move the 8 because the 8 does not have a negative exponent. It's just 8 to the first power, so that stays in the top. So we have 8 over x, the 1 over 15 power. All right, next batch of questions. We are solving equations with radicals and rational exponents. So for 13, we've got the cube root of y minus 2 equals 5. So step 1, the way we undo the cube root is by cubing both sides. So we're going to cube the cube root of y minus 2, and we have to do it to the other side as well. So then we're left with what's under the radical. So y minus 2 equals 5 cubed, which is 125. Then we add 2 to both sides. Y equals 127. For number 14, we have a rational exponent. So we have x minus 9 to the 1/3 power equals 3. So the way we undo a rational exponent is by raising it to the reciprocal power. So the reciprocal of 1/3 is 3 over 1, which is just 3. So we're cubing both sides again. So now these cancel out, and we're left with x minus 9 equals 3 cubed, which is 27. Then add 9 to both sides. X equals 36. So for 15, we have x to the 3/4 power equals 64. So again, the way we undo a rational exponent is by raising it to the reciprocal power. And the reciprocal here is 4 over 3. And we need to do it to both sides. So now we're left with these all cancel. X equals 64 to the 4/3 power. Now you could just put that in a calculator and find the answer, but I'm going to do it the long way. So since we have a 3 in the denominator, that's our root. So it's the cube root, 64 to the 4th power. Now the cube root of 64 is 4. So we have 4 to the 4th power, which is 4 times 4 times 4 times 4, which is 16 times 16, which is 256. All right, so last equation in this section. So number 16, again, we've got a cube root, 3x minus 1 equals 2. So once again, we're just going to cube both sides. And then we're left with what's under the radical. So 3x minus 1 equals 2 cubed, which is 8. And then you just solve the equation you're left with. So 3x equals 9. Divide by 3 on both sides. X equals 3. All right, so then now 17. So now we're into section 9.4. So for 17, I see a trinomial in the numerator and a trinomial in the denominator. So I'm going to factor the numerator. So what adds to 2 that multiplies to negative 24? That would be n plus 6, n plus 4. Sorry, that is a mistake. And minus 4. So 6 plus negative 4 equals 2. 6 times negative 4 equals negative 24. Denominator. What adds to negative 11? That multiplies to 28. That would be n minus 4 and n minus 7. So negative 4 plus negative 7 equals negative 11, and negative 4 times negative 7 equals positive 28. So then we can cancel out like factors in the numerator and denominator. So the ones we have exactly in common are n minus 4 and n minus 4. So we've got n plus 6 over n minus 7. And that was letter B. All right, so we're on 18 now. So for 18, I see a trinomial again in the numerator, and I see a difference of 2 squares in the denominator. So let's factor the numerator. So what adds to 8 that multiplies to 15? That would be 3 and 5. So n plus 3, n plus 5. In the denominator, we've got a difference of 2 squares. So a equals the square root of n squared, which is n. B equals the square root of 25, which is 5. So it's a plus b, a minus b. So n plus 5, n minus 5. And then we cancel out like factors. So n plus 5, n plus 5. And then we have n plus 3 over n minus 5. All right, we are on to the next page. So now we are multiplying expressions. So for 19, we have 3x cubed over 6y cubed times y to the 5th over x to the 5th. So first step is to multiply the numerators. So 3x cubed times y to the 5th over 6y, is that an x or y? 6y cubed times x to the 5th. All right, and then first thing I would like to do is reduce the coefficients. So we have a 3 and a 6. I can reduce that by 3, and I get 1 over 2. And then what we will do is, I think what made sense to a lot of people is writing out how many of each of these we have. So we have 3 x's in the top, and then we have 5 y's in the top. You can sort of do this in your head as well. You don't need to write it all out if you're able to do this in your head. So we had a coefficient of 1 in the top. Now we have a coefficient of 2 in the bottom. And then we have, let's put the x's first. So we have 5 x's, 1, 2, 3, 4, 5, and we have 3 y's, 1, 2, 3. So again, it might help you to write it out like this. You might be able to do this in your head. Either way is fine. So now we can cancel x's. That's it for x's. Then we cancel y's. That's it for y's. So we're left with 2 y's, y times y in the numerator. We're left with this 2 in the denominator and x times x. So that means we have y squared in the numerator and 2x squared in the denominator. All right, so for 20, there's a lot going on here. So for 20, we have x plus 2 squared over x minus 5 times x squared minus 2x over x squared minus 4. So first thing I want to do, I want to write that x plus 2 like squared like this, just so it's really clear that we have 2 different factors of x plus 2 over x minus 5. Now we're multiplying these together, so we need to multiply the numerators. Now this guy right here, we're going to factor a GCF out of that. So we have an x squared and an x, which means I'm going to factor an x out. And if I factor an x out, we're left with x minus 2. And then in the denominator, we've got x minus 5. And then this guy right here is a difference of 2 squares, where a is x and b is the square root of 4, which is 2. So it's x plus 2, x minus 2. So now we have a bunch of different factors here, and we cross out factors that are exactly the same. So first we've got this x minus 2 and x minus 2 right there. We've got an x plus 2 and an x plus 2. Now we're left with an x and an x plus 2 in the numerator and an x minus 5 in the denominator. So that's why, this is why I like to write this out as 2 factors, because we only crossed out one of them, not both of them. All right, so for 21, we've got another one of these with a bunch of monomials, so a bunch of letters. So d squared over ef times 5e to the 5th times f over 4 times d. So step 1 is to multiply. So when I'm multiplying these, I want to put my coefficient first. So I'm going to put that 5 first. And then we have d squared times e to the 5th times f in the numerator. Then in the denominator, I'm going to put this coefficient first. So we have 4. And then I kind of want to keep my letters together. So I'm going to do d first. So 4 times d times e times f. All right, so now let's look at this one piece at a time. So my coefficients, 5 over 4, can't reduce that, so I'm going to leave it. So then what you can do from here is you can do the same thing. Oops. You can do the same thing that I did in that other question where you write out all the letters. That'll work perfectly fine, but what I'm going to do is something different for people who don't prefer that. So we've got d squared over d to the 1st. So that means I can cancel out one of these d's. So if I take away one d, that means I'm left with d to the 1st in the numerator and no d's on the bottom. For these e's, I'm going to do the same thing. So I cancel out one of these and I take away one of these. Then I'm left with e to the 4th in the numerator and no e's on bottom. Then these f's, I can actually just cancel both of those out. So we're left with no f's. So we have 5 d e to the 4th over 4, which was letter A. All right, so 22, we have x minus 5 times x plus 9 over x squared minus 25. So step 1 is to put that over 1. So we have two fractions now. And then we multiply the numerators. So we have x minus 5 times x plus 9. And then the denominators. So 1 times x squared minus 25. So the numerator is already factored. X minus 5 times x plus 9. The denominator is a difference of two squares, where a is the square root of x squared, which is x, and b is the square root of 25, which is 5. So it's going to be x plus 5, x minus 5. And then we cancel out factors that are exactly the same. So that would be x 5 and x minus 5. And then we're left with x plus 9 over x plus 5, which is letter C. All right, so the last few questions, we have division now. So for 23, we have x squared minus 36 over x plus 5 divided by x plus 6. So that x plus 6, we need to put that over 1 first of all. And then we do keep, change, flip, and then we just multiply. So multiply the numerators together. So we would have x squared minus 36 times 1 in the numerator. And then in the denominator, we have x plus 5, x plus 6. Do not actually multiply those together. You want to leave those as factors so that you can cancel things out. So x squared minus 36 is x plus 6, x minus 6. That's a difference of two squares. And then you have x plus 5, x plus 6 in the denominator. So you cancel those and you're left with x minus 6 over x plus 5, which is letter C. 24, we have 3x squared plus 18x over 6 divided by x plus 6. So again, we need to put that over 1. And then we do keep, change, flip, and then we factor. So the only thing that we have to factor here is this 13x squared plus 18x, and I'm going to take a GCF out of that. So first of all, we have a 3 and an 18. 3 goes into both of those, so we'll take a 3 out. And then we have x squared and x, so we'll take it out in x. And then if we take out a 3x from 3x squared, we're just left with x. Then if we take a 3x out of 18x, we're just left with 6. So we have that over 6 times 1 over x plus 6. So 1 over x plus 6. And then we can go like this. Final step, we have 3x over 6. Let's reduce those coefficients by 3. So we have 1 over 2. So then we have 1 times x over 2. All right, last one, 25. So we have x squared plus 11x plus 30 over x squared minus 25 divided by x plus 6 over x minus 6. We do keep. Change, flip, and then we multiply. Let's do the multiplication before we factor this time. So put all these in parentheses, multiply x squared plus 11x, plus 30 times x minus 6 over x squared minus 25 times x plus 6. So first of all, let's factor this trinomial right here. So what adds to 11 that multiplies to 30? Well, that's going to be x plus 5, x plus 6, and then we also have that x minus 6 in the numerator. And then in the denominator, we have x squared minus 25, which is a difference of 2 squares, where a is the square root of x squared, which is x, and b is the square root of 25, which is 5. So we have x plus 5, x minus 5 times x plus 6. So that's just this x plus 6 right here. And then we cancel out factors that are exactly the same. So this should be a 5. Sorry about that. That was x plus 5, x minus 5. So then we have x plus 5, x plus 5, x plus 6, x plus 6. And then we're left with x minus 6 over x minus 5. And that's it.